Alright, we're going to talk a little bit about rotations. So we've talked about some of these other transformations and things throughout the year. We've mentioned them as we've talked about other things, but rotations are one of those ones that doesn't really come up anywhere else. So dilations we did when we were multiplying fractions. Transformations we also kind of did because you're just adding and moving it around. Reflections, you're multiplying it by -1. So this one doesn't really come up because it doesn't work that way. So we want to do, there's 3 different rotations. There's 90 degrees, 180 degrees, 270 degrees, and you can do that either clockwise or counterclockwise. So this one wants us to rotate 180 degrees, and I didn't write clockwise, but 180 degrees clockwise about the vertex x. So there are 4 coordinates there, so you want to make sure to go ahead and plot those points, and if you need to pause the video, go ahead, because I've already plotted those 4 points. So we have w is at -4, -1, x is at -2, 0, and y is at -1, -3, and then z is at -2, -4. They want us to rotate that about vertex x. So what that means is x is our center of rotation. So x is actually going to stay the same. So this point doesn't move because we're rotating it around that point. So that point doesn't move. What we want to do really is say, okay, if I want to move this whole line, this whole side around 180 degrees. So think about what's the slope between this point and this point. I go up 1 and over 2, right? So I'm going to continue that because I want to make that straight line going the other direction. So we're going to go up 1 and over 2. So this is my new W prime is what we call it. We put the little apostrophe there if you can see it. We put a little apostrophe because it's W prime. It's the new W point. So now this point, actually I'm going to give it a different color there. Make the black the prime figures. So then our line is going to come up from x, because x, remember, is going to stay the same to w. Well, then we want to continue all these straight lines. So to get to our y, this slope, we would continue, we'd go up 1, 2, 3, and then over 1. So we're going to go up 1, 2, 3, and over 1. So this is going to be our new y prime. So then we would connect x to that. Then we have to have the z. Well, z is directly below x, and we just move down 4. So now we're just going to move up 4. 1, 2, 3, 4. Here's going to be our new z prime. And we simply just rotated that figure 180 degrees. Now notice x is the same as x prime, so that's all the same. Because again, we rotated about the x value, we didn't actually move the x value. And they want us to write the coordinates of the new image. So we would say x prime is the same as x. So that was -2, 0. And we have w prime, so we'll just go around, is going to be at 1, 0. Z prime is next. And that is at -2, 4. And then y prime is at -3, 3. And those are our 4 new coordinates after we rotated it 180 degrees. Alright, we're going to go ahead and look at a 270 degree rotation, because I think these ones are a little more difficult. Let's go ahead and take a look. They want us to rotate. Let me see, I believe it's, yeah, clockwise, 270 degrees clockwise about, which means around, the origin. So this time we're doing it around the center of the graph. So again, we're going to go ahead and sketch a graph out. And the coordinates we're looking at, first one, so I'll put these over here. Just doing a triangle, so it's A, B, and C. A is at 2, -5. B is at 4, -4. And C is at 2, -1. So let's go and plot those. 2, -5 is A. 4, -4 is B. And C is 2, -1. Now a 270 degrees, this is 3/4 of a turn. Clockwise, so we're going around this direction. Well, that's also the same as saying 90 degrees counterclockwise, because you can either go 90 degrees back this way or 270 degrees around this way. Well, an easy way, in my opinion, to do this is to look at the slopes. If I look at the slope, because remember we're rotating it around the origin, if I look at this slope from here back to the origin, we go up 2 and over 1. What you want to do is flip those two numbers. So we go up 1 in this direction 2. So then we're going to go up 2 in this direction 1. So the slope here was a negative down 1 over 2. It was a -1/2. But then I switched it from the origin, and we then went, because remember we're going back this way 90 degrees, so it's perpendicular. So if I make a little line here, from here to here, this is 90 degrees. The line from here should be 90 degrees to that line. And then that's going to give me a rotation of 270 degrees this way. So now this is my new C prime. So then we do that with the rest of these. So then we're going to flip around the other way, and it's not 180 degrees, it's 270 degrees. So again, if I get rid of all of this stuff in here, because we just did the C value, so let me show you what that's going to look like with the rest of these. Again, I think slope is an easy way to look at this. So then again, let's take the A value. To get from here back to the origin, because that's our rotation piece, we would go up 1, 2, 3, 4, 5 over 2. So the slope from here to here, that slope is a -5 over 2. What we do is we take the reciprocal. We flip-flop those, so it's now 2 over 5, and it's positive. So from here we go 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 5. This is now A prime. So if I drew the lines, there's this one, and then there's this one, which should create for me a 90-degree angle. So now this is, so again, I'm going to erase this because that's not part of my figure. It's just part of how we get there. So then this is my triangle. Then again, from B to the origin, we would go up 1, 2, 3, 4, 1, 2, 3, 4. So it's a negative 1, right? So we go positive 1. We go up 1, 2, 3, 4, over 1, 2, 3, 4. This is b prime. If you look, we've now just rotated that thing 270 degrees. So we're going to spend a little more time doing these more complex rotations in class, because I don't expect you to grab hold of that right away. However, you're looking at slopes, because really what we did is we counteracted that. We went backwards 90 degrees, which is why I was looking for those perpendiculars. I wanted it to create 90-degree angles, because then the other half of that, then the other piece of that would be the 270 degrees. So those are the only two examples we're going to do. There are some things about rotational symmetry, but I think you guys should have talked about those in other classes, so we're not going to worry about rotational symmetry. Because that just means if you rotate it, it looks the same in different perspectives. So we will spend some more time in class talking about rotations.